In this video I want to show you how to process an NMR using the program Mestrenova. So you need to have the program installed in your computer and also to have downloaded the files that we need, that we get from the spectrometer. So first of all we have to browse looking for the folder that contains the files. In this case will be this one that says aspirin, and we have here 3 different folders. Each of them corresponds to one different experiment that we want to take. So we will open the first one that corresponds to the proton NMR. We have here several different files. The one that we carry is the FID file. So we open this one, and here is the spectrum. You can see that in this spectrum, if we have a look at the program, we can see here that we have several different icons that correspond to different actions that you can take on the spectrum. For instance, we can increase and decrease the intensity by picking in this icon. We can also do that with the wheel of the mouse. We can make an expansion by picking and dragging with this magnifying glass signal, and we can recover the initial spectrum just by going from the complete spectrum. The first thing that you have to do once you have the spectrum on your screen is the correction of the phase. In this case, the phase is perfect. The baseline is very nice, so we don't need to do anything with that. But it might happen that sometimes we find a distorted baseline, such as this. And then we need to correct the baseline by making the phase correction. So we go to the symbol here that represents something which is out of phase. We set manual correction. We take the cursor, we place it on top of this character which is in bold. We pick and drag, and by picking and dragging you see how this is changing, and we leave it until we leave very perfect baseline. Sometimes it might happen that we need to make some further correction other than this one, because we don't manage to correct the phase by using only this button, and we might need to use the right button and placing this cursor here over the pH1. So we close the window now, and the next thing that we have to do is to reference the spectrum. This means to give a particular value of chemical shift for one of the signals that we have in the spectrum. Typically, it is used the tetramethylsilane, and we give the reference of 0. So we go here for the TMS signal, then we have this red line that appears here. We select it, and we give the value of 0 ppm, or we can also choose that value from this table. Tetramethylsilane 0 ppm. In some cases, we don't have tetramethylsilane in our sample, because to have this signal of the tetramethylsilane we need to have introduced it in the solvent. When we don't have the tetramethylsilane in the solvent, we can also adjust by looking for the residual signal of the solvent, which in our case this time is the chloroform that is present in the deuterated chloroform, and which is the signal here. So we go for the TMS, then we have again this line that appears, we place it here, and we choose the chemical shift for deuterated chloroform. There you have, we accept, and we have the system referenced with the deuterated chloroform. We can do then so the reference either on the tetramethylsilane or in the chloroform signal. So we have done the phase correction, the reference. Next thing that we'll do will be the integration of the spectrum. For the integration of the spectrum, we will use these options that come in this icon here of the integration, and we'll use the manual integration. But for making the integration in a precise way, it is recommended that we expand the different regions that we want to integrate. We'll start this time by the signal of the method. So we select manual integration, we pick and drag and then we have the signal which is being integrated. We recover the complete spectrum, and we go to this other region and select manual integration, pick and drag, pick and drag, pick and drag, pick and drag. So we have integrated all the signals. We could still integrate the signal here that corresponds to the hydrogen of the salicylic acid, of the acid that appears over 10 ppm. So we have the spectrum integrated, but if you look at the values that we have here for the integrals, this represent less than 1 nucleus, 0.33, and we know that each of these signals correspond to 1 proton. So we can normalize these values by saying that each of these will correspond to 1 proton. To do that, we need to go again to the integral option. We are now in the expansion option. We go to the integral option, we select manual, and now we have the cursor that represents an integral. So with the cursor, we place the cursor just here. We press the right button this time, and then these options appear. We say edit integral, and here we give the value that we want to give for normalizing the integrals, which is number 1, and then we press return, and we have 1, 1, 1, 1. So now we have the values which are normalized, and of course for the methyl group we have that corresponds to 3 protons. So there is the spectrum that we have, and then we want to list the peaks. The peak picking is the next thing that we have to do. So we select this icon here that corresponds for the detection of peaks, and as usual we will say manual, and as usual to do that it's better if we make an expansion. Select peak picking manual, we pick and drag, and everything which is included over the line will be listed. Again here, pick and drag, everything over the line will be listed, everything over the line, and here. So we have all these peaks that are represented here in the values. The units are ppm. We recover the complete spectrum, and we do the same thing for the methyl group. And that's it. We have our spectrum ready for being printed. However, in this spectrum we don't see the signals very well, and we might want to do an expansion and print this expansion also. We have one choice, which is just make this expansion and in a separate page print this figure here. Okay, so if we go here and say here print, we will print what we see. This is what we see is what we get type of program, so this is what we're going to get printed. But maybe we will want to have everything in one single page, and we can include the expansion in the same page. For doing that, you go to this new tool that allows us to create an expansion. So we select here, we see that this is selected, and now we take the region we want to expand by picking and dragging, and then we have this region in this new part of the spectrum. And see, with this tool here we can either decide that we work in the big spectrum or that we work in this other smaller one. So if now I want to increase or decrease the intensity, I'm doing it in this small spectrum, or if I want to make expansion, I'm doing it in this small spectrum. Using this tool I can also make this bigger, make this larger, or just moving it by pressing the arrow in the second square that we have. And we know we are working in this one because these green squares are in the small expansion. Now I would be working in the big ones. So let's go to the expansion. We don't need really the integrals here because we already have it there, so we can remove it. since I'm working in this small spectrum, I can go here, look for the integration, and say that they delete integrals. We don't need those integrals there. Also, we have up here the list in Hertz, sorry, in ppm, but it would be useful to have also a listing in Hertz that will enable the calculation of the coupling constants. To do that, we have to go to a new option, which we find here in Edit and Properties. There are many different options here. We can change the color of the lines, we can change some things in the integrals, and we go to peaks, and in peaks we can change the units. See here, units are in ppm. I want the units to be in Hertz, and also I want to get rid of this mark that they put. So by doing this, see that I keep the ppm listing in the main spectrum, but now I have the Hertz listing in the expansion, so it will be easier for me to calculate the coupling constants. Also, I have here these curves of the integrals messing around that are really not necessary because I have the data. Here I don't need to have the curves for the integrals of this spectrum that will be confusing. I can get rid of them. So I select the main spectrum, I go here in Properties, and go to the option of integrals and say that I don't want the curve. So now I have the spectrum, I have the expansion, but I don't have the curves that correspond to the different integrals. I adjust here the size so that there is no signal that comes with more intensity than necessary. I have here the complete spectrum. Finally, I can write down some information. For instance, I can say including a text file, which I could put, let's say, in here, saying that this is aspirin that the spectrum is taking in color form, and we could also make some more information such as it's being done at 300 megahertz. Now we can go and print it or export it to a PDF file.